In this video, we're going to try and sketch parametric curves by making use of horizontal and vertical tangents. So when given parametric equations, you can always find dy by dx by differentiating this. So when you differentiate it, it will give you this, and then differentiate this. That will then give you this. And in the previous video, we said that the horizontal tangent exists when this equals 0. And the vertical tangent exists when this equals 0. So to locate the horizontal tangent, let's set this to be 0. So to locate the horizontal tangent, set this thing here to be 0. So set that to be 0, and then find the time when that horizontal tangent exists. So the time at which that horizontal tangent exists is at time 1 and negative 1. Okay, so we know the horizontal tangent exists when the time is 1 and negative 1. So but the thing is, we know the time, but we don't know the location. So we need to find out the x and we need to find out the y location. So when time equals 1, put it into here. The x coordinate will be 1. When time equals 1, the y coordinate will be negative 2. And when time equals negative 1, when time is negative 1, x will be 1, y will be 2. So we know this. We know that when it's 1, 2, there exists a horizontal tangent. When time is at 1, we know that the location will be 1, negative 2. So we know the horizontal exists at this location and at this time. Okay, so when given these parametric equations here, you have to assume that the time starts at negative infinity and then it goes to positive infinity. So but the only thing that we know so far is there's going to be a horizontal tangent at time negative 1. So at time negative 1. And then we know there's a horizontal tangent when time is at positive 1. So now let's try and identify the vertical tangent. So to find out the vertical tangent, set this to be 0. So set this to be 0. The vertical tangent exists when time is 0. Okay, so now we know the vertical tangent exists when time equals 0. So put this into here. That will then give us the x coordinate. Put it into here. So when time equals 1, the x coordinate will be 0, the y coordinate will be 0. So we know that there must be a vertical tangent at time equals 0 and at location 0, 0. Okay, so far we know this, and we know the vertical tangent here, and we know the horizontal tangent here. So now consider the y-intercept. So consider when the graph will cross the y-axis. So it will cross the y-axis when we set x to be 0. Okay, so let's look at this here to identify. So now we've got this, and we've got this. Another piece of information that we can extract is the x intercept and the y intercept as well. So let's consider. Let's try and track down the y-intercept. So to obtain the y-intercept, set x to be 0, because suppose you have a graph, a curve looking like this. If x equals 0 is here, so to identify the y-intercept, set x to be 0. So set this to be 0. So set this to be 0. So to identify the y-intercept, set x to be 0. So we've got this thing here. So the y-intercept will exist when time equals the square root of 0 here, which is 0. So now we know the intercept. We know the y-intercept exists at x equals 0 and y equals 0. So we know the y-intercept. Now to locate the x-intercept, hang on. So to identify the x-intercept, So to identify the x-intercept, you would set y to be 0. So this is y equals 0. So we would need to set this to be 0 to identify the x-intercept. So set this to be 0. So hang on. So to identify the x-intercept, set this thing to be 0, and then t will be positive root 3 and negative root 3. So hang on. So when time equals negative root 3, x will be 3. So we know that it crosses the x-axis when time equals negative 3, and where it crosses the x-axis will be at 3. So it's going to be here. And then when time equals root 3, it also intersects at also 3. So what that means is, at this time here, it's going to cross at this precise point, and then at time root 3, it's going to cross at this same at this particular point. So what that means is, I don't know what's happening, but it's going to do something like this or whatever, and then at time root 3, it's going to come back to the same place. So it might do something like this, and then it's going to come back to this same point at root 3. So at time root 3, it's going to be here, and then it's going to do something, I don't know what, but by the time it gets to time root 3, it's going to be at the same place. So that's what we can obtain for that. So we know that at time root 3 is going to be here, and then don't forget, our time is from minus infinity to positive infinity. So at time root 3 is going to be here, and then the next point that we know is time negative 1, not positive 1. The next spot will be here. It will head towards here, and then this is time 0, so it's going to go something to here, and then time 1 here. So that's what we know. That's a sequence which we know. It will be somewhere here, and then it will go in this direction, and then it might even do something like this. But all that we know is that it's going to go there, and that's all we know so far. So to obtain more information, we would need to consider when time is negative infinity. So when time equals negative infinity, let's look at this. When time equals negative infinity, x here will be positive infinity. So when time equals negative infinity, x will be positive infinity. So when time equals negative infinity, let's consider where y will be. So when time equals negative infinity, to find out y, well, here you've got this block versus this block here. This block here will dominate this block, so we can pretty much forget about this. So when time equals negative infinity, this block will dominate. So if you have a negative very, very, very big, then this thing here will be negative very, very big. The point is that when time equals negative infinity, y will be negative infinity. So y will be negative infinity. So what that means is that when time is negative infinity, x is positive infinity, y will be negative infinity. So it's going to start somewhere down here. Remember, our time scale is from minus infinity to positive infinity. But when time is negative infinity, x will be positive infinity, y will be negative infinity. That would mean that we will start somewhere down here. We will start somewhere down here, and then we will hit this, and then we will hit this. We will hit this. We will hit this, and then we will go back to here. And then let's consider what happens when t is positive infinity. When t is positive infinity, x will be positive, y will be positive infinity. So when time is positive infinity, x will be positive infinity, y will be positive infinity. It's going to be somewhere up here. So we now know that it's going to do something like this. Okay. So if you get a graph plotter and plot it, it will give you this. So now we know it's going to do something like this. Okay. So if you get a graph plotter and plot it, it will give you this. Okay.